When courses require a solid foundation in robotics, the RTS-200 robot training system by SMC covers the operation, connection, and programming of standard robots used in automated processes. Our all-in-one training platform and guided curriculum are developed with a focus on industry standards. The training system is built and designed using industry-relevant components exactly like those found in manufacturing equipment for a seamless learning experience. Let's take a look at the key features and functions of the base RTS-200 robot training system. It includes an expanded work surface, which quickly lowers for transporting through standard doors. It utilizes modular application panels for expansion into advanced integration. It allows for addition of programmable controllers. It includes an open frame format for collaborative robots. Can include a fenceless format with safety scanner for non-collaborative robots. And expanded integration activities with electro-pneumatics, sensors, conveyors, programmable controllers, distributed I/O, 2D and 3D artificial vision, and robot guidance. Students enjoy the simple design of the training platform and easy-to-follow activities, as well as the robust learning modules. The curriculum for our base robot training system includes these 11 topics: Introduction to Robot Systems, Robot Startup and Commissioning, End-of-Arm Tooling, Program Creation, Joint, Linear, and Circle Motions, Path Following, Pick and Place Operations, Digital I/O, Configuration of Variables, Utilization of Timers, Subprograms, and if statements. Give your students the best learning opportunity with built-to-industry standards training systems from SMC. Learn more about the equipment, configure products, and review the curriculum at smctraining.com.
So here we have it, the RTS-200, or the technology trainer for competencies related to the industrial robotics. What does this product provide? It provides different applications or problems for the students to solve and develop their robotic programming skills. How does they do that? By having some modular applications that for example, fast screws, we can assemble and disassemble different applications, or in the case of the panels, we can exchange it very fast. So the applications have a modular design, but are also industrial-based. All of the components that we will find, all of the electrical connections, all of the pneumatic connections, the light banner, and the push buttons are industrial components, as well as the robot. If we focus on it, we can integrate the size of UR robot that we want. In this case, is UR5E, which has a reach of 850 millimeters, and with a weight of only 20 kilograms. It has a payload of 5 kilos, and all of the UR robots are industrial robots that are also collaborative. And this brings a lot of security in the manipulation and will reduce any risk of the students getting hurt during the training. The touch screen, the programming interface is a touch screen with a very simple to use interface. The learning curve of the programming of this robot is very efficient, and it will allow the students to very fast be confident with the basic functionality and advance easily towards the most advanced functionality. And in order to show you how fast it is to start programming your first application on the RTS, I'm going to begin programming the pick and place application, where I will move a product from the first picking position and move it to the second one. What you will see shortly is the programming interface seen by a computer using VNC. So that way you can see what I am programming right now. And the first step I'm going to do is to create a new project. with this button on the programming console, I will be able to move the robot around and approximate it to the first picking position. Once I have it near the picking position, I can establish the point or the weight point. I am able to align the robot after moving it by hand to align it on the set axis and finish orienting the tool to pick the product. So once we are happy with the picking position, we can actuate the gripper. So in this case, we are including a pneumatic gripper, but SMC has a wide range catalog for manipulators for industrial robots. So whether they are electric or pneumatic grippers or solutions with vacuum pads or magnetic manipulators. In this case, this is a pneumatic gripper. We can integrate any other SMC's grippers for collaborative robot or other collaborative manipulators. To actuate this pneumatic gripper, I will set the pneumatic output or the electric output to actuate the valve. The programming console allows us to test this instruction. So we can see that the gripper has actuate. And I will give some time for the gripper to activate and adding a wait instruction. With 1 second, it should be more than enough. Once I have the first picking position, I will like to add a second point just above this first waypoint. I will call it waypoint 1 of the first position and A as in above. And I will set it just a little bit higher than the first picking position. And I want this instruction to be made both in the first step, so I want the instruction or the movement to start from this above position, go down, pick the product, and go up again. And now I will move the robot to the place position. I will put the robot near the second position and start aligning the robot in the set axis and fine-tuning the position. So once I am happy with this position, I will as well activate the valve or to release the product. I can test it as well, and if I am happy, I will also program the above point. That will be the intermediate point from the first waypoint, and also we will put it in the last step in a second. So I will program it just above the second position, and I will also add it to the last step. And I also will add a timer after the release of the gripper. So now we are able to test what we have programmed. I will start the code from the beginning. I can see where the program will be started. And now when I click on play, I will see the instructions that I've programmed being executed in a recursive way. So, as you have seen, in just a matter of minutes, I am able to start programming our first RTS application, in this case, a pick-and-place operation. And as a student, I could move on to more advanced functions. For example, let's go to a path planning exercise. So, SMC already gives some code for the solution of the applications, so I will just execute the pre-programmed code. I will start the operation. Here I can see that the robot will start from the beginning position. And now when I click on the start push button, the operation will begin. This is a path planning or trajectory programming. And as this robot is a collaborative robot, the moment I get in the way of the robot movement, the robot will safely come to a stop. And I am able to re-enable the robot and continue the trajectory. So you have seen some applications the RTS has to offer that will allow the students to be familiar with robot programming and also the interaction between the robot and the rest of the elements in the robotic cell. If you want to know more about which applications we have to offer, check out this video.
Most industrial robots are integrated into larger systems that perform complex tasks and often communicate information and signals to other equipment. Expanding student knowledge beyond basic pick-and-place operations can be a valuable skill set in today's industries. While the RTS-200 training system from SMC includes base applications allowing familiarization of basic robot operations, the platform can be expanded to include industry-relevant applications that allow students to develop the skills required to integrate systems with industrial robots. Let's take a look at the expanded applications available for the RTS-200 robot training system. Electro-pneumatics and part transfer, which utilizes pneumatic actuators and sensors to transfer a part from one location to another. Part identification and sorting that utilizes various sensors to sort products according to material, dimensional measurement, and quality. Production application, utilizing a user interface to provide an order which will be fulfilled by the robot. Variable speed conveyor with sensors utilizing a belt conveyor that can transport products to or from the robot working area. Product assembly that allows the robot to retrieve parts from storage to build a completed product. CNC machine tending that simulates a CNC operation and the handshaking required between the robot and external machines. Programmable controllers and distributed I/O, which allow connection to external controllers via digital I/O or networking, using standard protocols such as Ethernet IP, Profinet, and Modbus. 2D and 3D artificial vision, which allows the use of vision sensors to identify and measure products, and can also provide coordinates for robot guidance. Each application panel can be quickly installed on the RTS system utilizing pre-wired interface modules and cables. This eliminates the time required for connecting each of the units directly to the robot controller. However, all connections allow participants to fully connect and integrate the system depending on the individual course requirements. Give your students the best learning opportunity with built-to-industry standards training systems from SMC. Learn more about the equipment, configure a product, and review the curriculum at smctraining.com.